This video was brought to you by Indently.io, learning Python made simple. How's it going, everyone? In today's video, we're going to be exploring all 39 keywords that you can find in Python. And just to show you where I'm getting this number of 39 from, I'm going to paste in the following code. And all it does is imports from keyword the keyword list and the soft keyword list, because I'm also going to be including the soft keywords. Then I have a function that loops through each one of these and displays the current keyword with its current position. And when we run this script, what we should get back are all of these keywords. As you can see, it's enumerated quite nicely, and it goes all the way down to 35, plus 4 soft keywords. And it's important to mention that we have 39 as of Python 3.12, because prior to Python 3.12, type was not considered a soft keyword. So on previous versions, this would give 38. And of course, case and match are also recent additions, so you might not have those depending on which Python version you are running. So yeah, I'm going to be showing you all of the keywords that are present in Python 3.12. Starting off with number 1, which is the false keyword. And false is one of the 2 states we can have in Python, the other one being true, and it's practically a constant for 0. So here I have a boolean called hasMoney, which is set to false, and then I'm going to print it, and to demonstrate that it just contains the value of 0, I'm going to print the integer version of false, so that when we run this script, in the console, you'll see that we will get false back, and that the integer of false is equal to 0. Moving on to number 2, none. None represents an absence of a value. There's no value if none is specified. So sometimes from the internet, you might get some data back, and that data might be empty, or it might actually contain absolutely nothing. And in that case, it's going to give you none. And when you print none, what you get back is none. Another example might be that you're trying to select a user in a database and the user you selected does not exist. So in Python, in general, you're either going to get an exception or you're going to get none back, which again represents an absence of a value. So here we were not able to select a user because it did not exist. And that's why we gave it the value of none. And if we were to print the selected user, we'd get none as an output once again. Keyword number 3, true. True is another constant for the integer value of 1. All it does is represent something being true. For example, if I have something such as has money, I can choose to set that to true or false to show that I have money or that I don't have money. And when we print that to the console, what we're going to get back is that boolean. And again, since these are just constants for the integer values, you can do something silly such as true plus true, and that will work just fine. You will get 2 as a response or as a return because true is just a constant for 1. Keyword number 4. Anytime you have some sort of if check or boolean comparison, you can choose to use and to check that 2 or more conditions return true. And everything inside this check must return true for this to pass. For example, here we're checking that C is more than B and that C is more than A. Both of these expressions have to be true for this print statement to get executed. And an easier to understand example might be if you have a name of Bob and an age of 19. And what you want to do here is check that this user is eligible to sign up for your website. So of course you will want to make sure that their name has more than 0 characters and that their age is more than 18. If both of these conditions are satisfied, this code will be executed. And this was possible thanks to and. As you can see, if we were to run this, the user is eligible to sign up because the length of the name is more than 0 and the age is more than 18. Moving on to keyword number 5, as. As is used to give an alias to a module. For example, if you're importing math, you can import it as m to keep it short. So now we don't have to explicitly refer to math each time we want to use the math module. We can just type in m and use dot notation to use any of its methods, such as cosine, and pass in 10. And this also works with specific functionality, such as from random, we can import the random integer as ri for random integer. Now we can directly refer to that by typing in ri and passing in 10 and 20. So this will generate a random integer in the range of 10 to 20, both endpoints being inclusive. And another place you'll see the as keyword being used is with context managers. For example, if you're trying to open a text file, you might want to give it an alias such as file when you are working with it or when the file is actually open. So here we can type in with open text as file and then work with that file inside here. Keyword number 6, assert. Very often when you're creating a program, you're going to have some minimum requirements for what is needed for your program to actually run. For example, maybe your program relies on a database that is built in to your device. If this database is missing at any point in the program, then your program was doomed from the start and shouldn't run no matter what. So one thing you can do inside your program is use the assert keyword, and assert just makes sure that whatever condition you insert is satisfied before moving on. Otherwise, it's going to raise an assertion error. So in this example, we have a database and we have provided that database. So this database should always be here. And if we were to run this, it will run just fine because we have that database. But at any point, if that database was to disappear, then the next time we were to run our program, we would get an assertion error that we cannot run the program without the database. And once again, you can use the assert keyword with any kind of Boolean expression. So we can even perform a check such as this one. And here I have a variable called limit, which is of type integer, and a number, which I just called n. So what we want to do here is check that the number of n is under the limit. And as long as that's true, our program's going to work just fine. It's going to be able to move on with the code. But as soon as this becomes false, for example, if we change this to 20, it's going to raise an assertion error. Keyword number 7. And for this keyword, we're going to have to import a built-in module called async IO. And that's because in Python, we use async IO to perform asynchronous tasks. And this is an example of what it can look like in its bare form. Here I have a function called main, which I want to execute asynchronously. So in front of def, I included the async keyword. And since this is asynchronous code, we need to run it in an event loop. And that's why I imported async IO. And asynchronous programming is a huge topic, so I'm not going to explain it here. Moving on to keyword number 8, await. And await is actually a keyword that we use with asynchronous programming or with async IO. So in this example, I'm going to import async IO, and from async IO, I'm going to import the future type. Then I'm going to create this async function called myTask, and it takes a number as an integer. And this is just going to simulate that we're starting a task and that we are returning some data. But as you can see, immediately we have an await keyword inside here. And all that's saying is that we want to wait for this to finish before moving on. Then in my main entry point, I've created some tasks, which is going to return a future. And I'm going to start all of these tasks asynchronously. And once again, before we actually print the results of these tasks, we're going to want to await them. So that just makes sure that we actually wait for the results before printing them, because it doesn't really make sense to print results that don't exist just yet. And then once again, we need to run it in a main loop. But now if we were to run this, it's going to start all the tasks asynchronously, and as soon as we get the results back, it's going to await them and return them. Keyword number 9, break. Whenever you're in a loop, such as a for loop, and you want to exit out of it prematurely, then you should use the break keyword. In this example, we have a for loop that loops through the range of 10, and if I is equal to 5, it's going to break out of this loop, which means it's not going to continue any further with this loop. Otherwise, it's going to print I. So by providing that condition with break, you'll see that we're not going to count past 4. Keyword number 10. Class. Anytime you want to create a class in Python, you're going to want to use the class keyword. For example, here I have a class called person, and all this does is provide a blueprint for how our person should look like. So our person should contain a name, and all our person can do is work, because life is miserable. Keyword number 11. Continue. Suppose you have some names which are a list of type string and that it contains Tom, Bob, and James. And next, suppose you want to loop through these names, so for name in names, and say hello to everyone besides Bob. So the way we're going to do this here is check if name is equal to Bob, print that we do not say hello to Bob. he does not deserve it. And then we can add the continue keyword. And what continue does here is say, okay, we ran into this, ignore the rest of the code. Just go to the next iteration. So print hello will not be executed for Bob because continue will force the for loop to skip to the next iteration. So if we were to run this, it's going to end up looking like this. Hello Tom, we do not say hello to Bob, and hello James. As you can see, this statement was ignored as soon as we ran into continue. Now, before we continue with this video, I just want to mention very briefly that if you are interested in developing your Python skills so that you can start using them more professionally, then check out Indently.io. On my website, I provide plenty of premium courses which are designed to help you achieve a much more professional level of programming much faster. So if that interests you, go to Indently.io, select a course, and start learning. Continuing with keyword number 12, def, which can also be referred to as definition or define. Usually I read it as define because here we're defining a function name to perform the following actions. In other programming languages, you might have something such as func or even fn, but in Python, we use def. Keyword number 13, delete. In Python, if you ever have some sort of object that you don't want anymore, for example, this name, and looking at this, I think I was pretty high or something to give my name an integer with the value of 10. Anyway, that's not the point. If you have some object that you created and you want to delete, you can do that using the delete keyword. So here I create this random variable called name with the value of 10, and later on I delete it. So if we were to run this, the first time we're going to get the value back, but the second time we refer to it, we're going to get this name error. Up next, we have keyword number 14, elif, or else if. And elif is used as the middle layer in if-else checks. For example, you might be checking for some weather. So right now we have the weather, which is rainy, and the first if statement is going to check if the weather is rainy. But of course, we might have other conditions to check for. So instead of just checking if it is raining, we can also check else if the weather is cloudy. But in Python, we refer to it as elif. And we can use as many of these as we like. So now we can check whether the weather is cloudy and whether the weather is sunny. That was a very difficult sentence. But while we're here, let's also talk about keyword number 15, which is the else keyword. And here, else is only going to execute this code if none of these conditions are met. Keyword number 16, except. In this example, I created some dangerous code, which always raises an error. And then below, I tried to run this dangerous code, which obviously will not work because it always raises a value error. But in Python, we can catch exceptions using the except keyword. So now we're accepting this value error as E. So each time we run into this value error, it's going to print, yo, you messed up, with the value of that value error. As you can see, when we run this, it's going to say, yo, you messed up, bad value. And while we're here, we can move on to keyword number 17, which is the finally keyword. And finally runs no matter what happens in the try and except block. So even if you return a value here, or you raise another exception here, this block will always be executed. Moving on to keyword number 18, which is the for keyword. And for this example, I created some elements which are a list of type any, and they contain these random values. And then I'm using the for keyword to say that for each one of these elements, we're going to do the following. So for is used for loops and iterations. Keyword number 19, from. Sometimes in Python, you're going to want to import some very specific functionality. And to do so, you're going to have to use the from keyword. For example, if you want to import random integer from random, you're going to have to type in from random import random int. And just like that, we're going to be able to use that functionality directly. Keyword number 20, global. Global is used to refer to objects in the global namespace. For example, here we have a name of Bob, which we defined in the global scope. Now, to actually make sure that we're referring to this name here, we're going to have to say global name inside our function. Otherwise, Without that, we're going to create a new name called James inside here because we are not referring to the name in the global scope. We're creating a whole new name in the local scope. So global just allows us to refer to the correct object in the global scope when we are working with functions and classes and anything that has been encapsulated. As you can see, if we were to run this, we would get James as an output because here we defined the name to be Bob, and then we referred to Bob in the global scope, and we changed that to James. And after we called this function, we could see that name was effectively changed to James. Keyword number 21, if. And we've already covered else and elif, so I guess logically we're going backwards, and the next one we have to cover is if, which is used for Boolean expressions. And all it does is tell Python to check whether this condition is true or false. And if it's true, it's going to execute the following block. So right now we have an age of 137, and we're checking whether the age is more than 100. And if it is, it's going to execute, wow, good job, mate. Keyword number 22, import. And again, we're working backwards because we've already used import a lot in this video. But import is just used to import packages and modules. For example, we can import random, and then we can print something such as random.random, and that's going to give us a random float back. Up next, we have keyword number 23, in. And there are actually two places we can use this. The first one being in a for loop. So every time you want to check that a certain name or a certain element is in an iterable, you can do that using the in keyword. So this will loop through all the names, and for each iteration, it's going to give the current element the alias of name. But we can also use n to perform membership checks. For example, we can check if Bob is inside the names. And if Bob is inside the names, we can write that we found Bob. Moving on to keyword number 24, is. And to quickly demonstrate what it is, I've created this class of type fruit. It doesn't contain anything, but it will be used for this example. And right below, I create an instance of this fruit, and I'm calling it apple. And then I create a second variable called other apple, which just points to the original apple. And the reason I'm doing this is to show you what is does. So next I'm going to print that apple is the other apple. And this is going to return to us true because both of these point to the exact same location in memory. And in other words, they are the exact same object. Otherwise, if we were to create another fruit, and we were to call this fruit banana, you would notice that we're going to get false back because they are not the same object. And it's important to note that is does not compare the value, it compares the memory address. And to get an idea of what it's comparing, I'm going to print the ID of each one of these objects. And when we run that, you'll see that these two are going to return true because they share the exact same ID, while banana does not. So obviously it's going to return false because this ID is not equal to this ID. Keyword number 25, lambda. And a lambda is what we refer to as a nameless function. And here's a bad example of what it looks like. And the reason this is a bad example is because in general, you would not assign it to a variable, or at least you wouldn't do it that often. But as you can see, here we have a lambda that takes x as an input or as an argument, and then that uses x in that one-liner. And since we assigned this to p, we can now use it as a function. But there's nothing that will stop us from using it directly inside parentheses. So we can do lambda and then insert the argument here, because this part here creates that function in place. And a better example would be if we had a function that takes a function as an argument, because then we can just place in a lambda inside here instead of creating a whole fresh function. But for this example, I have a function that prints the results of whatever this function does to these elements. So for each element in the elements, we're going to call that function on the current element. And the only reason I did this is to show you that we can use a lambda here. So instead of creating a function and inserting that function here, we can directly say that lambda x with x times 2, because we want to multiply each one of the elements by 2. And the elements are just going to equal this list of 1, 2, 3, and 4. And if we were to run this, we will get each number doubled. And it's quite nice if we don't expect to use this functionality more than once. Keyword number 26, nonlocal. For this example, I created a function, and inside this function, I created an item of type string that contains the text of candle. But right below that, I created an inner function. And once again, just like with the global keyword, the only way to refer to the candle or this item in the outer scope is to use one of these special keywords. So here we're using the nonlocal keyword to tell Python that we're referring to this candle here and not referring to the one that we're going to create in the local scope. And this is useful because if we want to do something else, like create another item inside here, if we were to type in item is equal to apple, this would create an apple in the local scope, and it would not refer to the one from the outside. But if we want to make sure that we're referring to the one from the outer scope, we're going to have to use the nonlocal keyword and say nonlocal item, and then we will easily be able to change it to apple. And whether this is a good practice or not with the global and the nonlocal keyword is a whole other discussion. So make sure to do some extensive research on those subjects when you have the time. Moving on to keyword number 27, not. In this example, I have some names of type list of string, which are equal to Bob, Tom, James, and Jeff. And what we want to do next is check whether Bob is not in the names. So that's a very simple way to negate what we did originally when we checked that Bob was in the names. We can do the exact opposite by adding the not keyword. So if Bob is not in the names, we can print that Bob is lost. Another use case of using not is with optionals or with the none type. For example, here we have an optional called selected user, which is of type string or none. And the reason this is an optional is because the user might have selected a user or might not have selected a user. So if the selected user is not none, that means the user exists. And with that, we can print that you have selected the selected user. Otherwise, it's going to print that there is no user selected. And this was the proper way to check whether something is not none. We are not supposed to use the comparison operators here. Python will not be happy with that. Keyword number 28, or. So here we're going to have three variables, one called A, one called B, and one called C, and they're going to have these respective values. Now imagine you want to check for multiple conditions, such as whether C is more than A or A is equal to B. By using this or keyword, we're telling Python that only one of these conditions have to be satisfied for this line to be executed. If both of these fail, this will not be executed. But right now this will succeed because C is more than A. 20 is more than 5, even if A is not equal to B. This returns true and this returns false. But or, once again, only checks that one of these conditions are true. So obviously this is going to work. Otherwise, once again, if both of these statements or expressions return to us false, it's going to return false. Keyword number 29, pass. In Python, if you need to define a placeholder for a function or a class or for a for loop, you can do so by passing in pass. The reason we have this is because Python does not allow us to insert nothing when creating a function. It doesn't really understand what we're doing next. So here we are obliged to either pass in pass or an ellipses. And I often opt in for the ellipses, but it's really just a matter of preference. I mean, one micro argument for using ellipses is that it's literally 3 dots, which you can type out much faster than pass. But that's a really silly argument, so just pick the one you prefer to use and the one that's more readable for yourself. Keyword number 30, raise. In Python, we use the raise keyword to manually raise an exception, such as this one over here. By using the raise keyword, we can tell Python that, hey, on this line, we want to raise that exception, and it will do so. Up next, we have keyword number 31, and this is the return keyword. And return is very useful for returning a value from a function, because sometimes you're going to want to get a value back when you create a function. For example, here I have a function called getTime, and with this name, one would probably expect to get a value back. And that's exactly what we're going to do. We're going to specify that we're going to return a string, and then we're going to get that date and time and return it as a string using this return keyword. But something you should know is that all functions by default return none. Even if you don't see it written anywhere, Python is going to do this for you. But here we are returning the current date and time. And when we print that, we should get something like this back. Keyword number 32, try. And we already covered except and raise, so now it's time we cover what try does. And in Python, we use try to run dangerous code or code that might raise an exception. For example, here we are trying to calculate a result, and the result will depend on this calculation here, which is 1 million divided by 0. And obviously, it's going to give us back a 0 division error. But we were able to run this code, which will obviously fail, inside the try block, so that in case it raised an exception, it would not crash our program, if we handled it. But if we were to run this, you'll see that trying to run this code will give us back the message of "Go home, Bob, you're drunk." And you can insert any kind of code you want, but usually you'll insert code that possibly raises an exception, such as converting some user input to a float. Because if they were to enter the number of 10, Python doesn't really know how to handle that. So this would be the perfect code to insert inside a try block. Moving on to keyword number 33, while. And while is used for while loops. And in this example, I created a connection, or something that simulates a connection. So first I imported time, then I created a boolean of isConnected, and I created a variable called I, which contains the value of 1. Now, while we are connected, I want to print that we have been connected for that amount of seconds and then sleep for 1 second. And on each iteration, I'm going to increment I by 1, because otherwise we're going to have this loop executed forever. But just to simulate that our connection eventually fails, I decided to specify an if block, which checks whether I is equal to 3, and if it is, it cancels the connection. But now, if we were to run this, it's going to say connected for 1 second, 2 seconds, 3 seconds, and then the connection will have been lost, because isConnected eventually evaluated to false. Otherwise, while is also really good for creating infinite loops, and you can do so by typing in while true. Keyword number 34. When Python was first created, we had to go through a lot of trouble. And when I say we, I mean the experts from the past, because I just started using Python about 4 years ago. But back in the past, like very far back in the past, we had to go through a lot of trouble to work with context managers. We would have to do something such as open a file, and then we would have to make sure to close that file. And in case anything went wrong, we would have to use the finally block to make sure that everything was closed nicely. But we live in the future, and we have good functionality for that makes it much easier to work with context managers. For example, imagine you have a text file that you want to open. Well, in Python, we can use the with block to do that. So with open this text file in read mode as file, do the following. And the benefit of using the with block here is that it will always close the file. So we don't have to create any complicated try, except, and finally blocks. It handles it all within this block. So that's a lot of free functionality. And if we were to run this, we will get back whatever's inside the text file that I created. Keyword number 35, yield. In Python, we use the yield keyword to create generators. So if we were to create a generator such as generate numbers that takes a limit and returns to us a generator, we would have to use the yield keyword to specify or to tell Python that this is actually a generator. And we can use this generator by doing the following. So here I'm going to create some numbers of type generator, and that's going to generate the numbers with a limit of 10. Now, each time we want to grab a number from the generator, we can use the built-in next method. So we can do that once, twice, maybe 3 times. And for the rest of the numbers, I'm just going to convert it to a list. And it's important to note that generators are exhaustive, which means that once you yield a value, it disappears from that generator. And that's why we get this crazy output, because each time we retrieve a value from our generator, it disappears from that generator. So calling list on whatever remains will give us back whatever we haven't used just yet. Moving on to the soft keywords. And the very soft keyword we're going to cover is the underscore. And underscore has many use cases, so I'm not going to be able to cover all of them here, but it's just important to know that in some cases it's going to be considered a keyword, and in other cases you can just use it as a variable name, such as that. In general, you would use it as a variable name if it is a throwaway variable. And a throwaway variable is just something that you don't expect to refer to. For example, here we want to print hello 3 times using a for loop. But in this scenario, we do not care about the actual value that's inside the range. So it's the perfect place to define an underscore. But one place where the underscore actually becomes very useful is when you define a dunder method in a class. As you can see, to define a dunder method, we need 2 leading underscores and 2 trailing underscores. And Python uses those to define dunder methods. And there are plenty of other cases for using the underscore in Python. Another case is literally for the case keyword. And yes, I worked hard to set that transition up. So now we're moving on to soft keyword number 37, which is case itself. And case is used in match case statements. And for this example, we're going back to the weather. So right now it is raining, and what we want to do is check what the weather variable contains. In the case of rain, we're going to print not again. In case it's cloudy, I recommend you use some cloud cream. Otherwise, for all the other cases, it's going to print unknown weather. Damn you, global warming, shakes fist. And as you can see, once again, we have the underscore being used as a soft keyword. But let's move on to soft keyword number 38. And soft keyword number 38 is the match keyword. And here I changed our example just a bit because I want to show you the power of pattern matching in Python. But in this case, instead of just checking for the weather, we're also going to be checking for its severity. So once again, we're using the match soft keyword to check for the value of weather. And in the case that it is rain with a severity of less than or equal to 5, it's going to print rain with that severity. Now, if it has the case of rain with a severity of more than 5, it's going to print very hard rain with that severity. And for cloudy, it doesn't really matter what severity it is, it's just going to print that severity. But just to show you how it works, right now we have rain with a severity of 6. So what we're going to get back is very hard rain with a severity of 6. Now, if we were to put cloudy with a severity of over 9,000, we will get our cloudy print message back, which is cloud cream, anyone with a very high severity. And finally, as of Python 3.12, type has become a soft keyword, which means we can now use it to define custom types, such as this type of int or string. And with this new type, we can use it with our variables to check whether it is an integer or a string. But if it's anything else, it's going to give us a warning back. And static type checkers are not going to be happy about this. And very briefly, I just want to mention that a soft keyword is something that you can both use as a variable name and as functionality that is built into Python. So we can use match as a variable name, or we can use match in match case. So we can actually match, if I understand correctly, which is incredibly confusing, so don't do that. But we can match, and then we can use case and do whatever we want. So case number is 10. And this will work just fine. If you want to make this really confusing, you can even do case is equal to 10 and put case. As ridiculous as this might sound, it works because you can use it both as a keyword and as a variable name. But anyways, those were the 39 keywords and soft keywords that we have in Python. I really hope you guys enjoyed this video. It took a lot of work. I thought it was going to be maybe a 10-minute video, but it ended up taking maybe an hour and a half to record. So now I'm going to edit all of that. And of course, I would love to hear your thoughts in the comment section down below if you have any. Otherwise, as always, thanks for watching, and I'll see you in the next video.